Greetings everybody, and welcome to our first example of cross products. So what we're asked to do in this particular problem is really just compute the cross product of two vectors. And so how we can do that, we can actually do it in a couple of different ways. One way using the definition, and the other way using the algebraic properties that we talked about in the previous video. Well, if we want to use the algebraic properties, then we can say that u is just going to be the vector 2i plus 6j and then minus k. Our vector v will be minus I minus j. So if we're doing the if we're doing the cross product of those two vectors, so u cross v, that's going to be a 2i plus 6j minus k crossed with a minus I minus j. Well, remember that when we're computing the cross product algebraically, that we have the properties that I cross j is going to give us k, and then we permute cyclically in that. So if we just shift the j over, so j cross k is going to give us I, and k cross I is going to give us j. And then along with that, if we have a cross product of a vector with itself, so I cross I is going to be the same as j cross j is the same as k cross k, and that will give us the 0 vector. So if we use these values to compute the cross product, what we have, just using the distribution, that we can distribute I cross all three of those vectors. Well, I cross I is going to give us 0. And so we have a 6 times a minus 1, so we have a minus 6 of our j cross I. And then we have a plus, negative 1 times negative 1 gives us a positive 1 of our k cross I. Doing the same thing with the j, so we can distribute that one as well. We have a minus 2 I cross j. Then our minus j cross j is going to give us a 0. And so then we're just left with a minus 1 times a minus 1, so a plus our k cross j. So now kind of evaluating those with respect to the vectors that we have in our cyclical permutation, j cross I is going to be, since that is the reverse order of I cross j, remember that gives us a negative, so that gives us a negative k. K cross I is going to give us a j, and I cross j is going to give us a k. And k cross j is the reverse of j cross k, so that gives us a negative, and so we have a minus I out of that. So now kind of putting these all together, we are going to have a minus I, and then a plus j, and finally we're going to have a 6 minus 2k, or really as a final answer, minus I plus j plus 4k. So this is how it would look if we want to compute the vector kind of algebraically. If we use the definition, what we're going to have would be something like this. So that using the definition, if we have two vectors u cross v, then the definition of the cross product is just going to be our u2 v3 minus u3 v2 as our first component. For our second component, we've got a negative of u1 v3 minus u3 v1. And then finally, for our third component, we have u1 v2 minus u2 v1. And so going back to our vectors now, we have u cross v is going to be the vector 2, 6, -1, crossed with our vector -1, -1, 0. And so kind of plugging in our values, now we have u1, u2, u3, v1, v2, and v3. And so we're going to get a value of u2, v3. So we've got a 6 times a 0 minus u3, v2, which gives us a -1 times a -1. Then we have a negative u1, v3, so we have a 2 times 0 minus u3, v1, which is going to give us a -1 times -1. And then finally, we have our u1, v2, which is going to give us a 2 times a -1 minus a u2, v1, which is going to give us a 6 times a -1. Well, if we clean these values up, what we see is that we have a -1 times -1 with a negative. So we have a -1 for our first component. For our second component, we have 0 minus 1, which is going to be a -1, times the negative out front, so that becomes a +1. And then finally, for our third component, we have a -2, and then +6, which is going to give us a +4 for our answer. And so either way, we end up with the same answer of -I plus j plus 4k. So I hope you enjoyed this video, and I will see you guys in the next problem. Take care.